Welcome back to Mastering C++ 20 Features. In the last lecture, we looked at two very simple unconstrained generic functions and the problem that may arise when they are used outside of their boundaries, which may not have been conceived by the author of the generic functions, and thereby try to motivate the idea that we as programmers need to specify the constraints and requirements more carefully in the generic program. Later in the function, we explicitly wrote down the requirements for each of add1 and add2container methods and realized that the requirements are in some cases very obvious. For example, the parameter value in case of add1 must be a numeric type, and we need special treatment when the parameter is a address type or a pointer type. And in some cases, the requirements on parameters are not so obvious, like the second parameter value in the method add2container. In this case, the not so obvious constraint or requirement was that the parameter value must be a copyable object. And if the value is not copyable object, which in case of std unique pointer, std jthread, std thread, std future, and std promise, and many other types in modern C++ is true, we can get really messy and bad compiler error. Before C++ 20, specifying requirements on generic code was possible with the use of type traits and sphnetrix, but they were cumbersome and were sometimes not helpful by just reading the declaration of function if they are requirements or are altering the types in some way or other by removing CV qualifiers, for example. With C++ 20's concept, we finally can specify requirements on generic function and constraint template parameter as a part of the program, which can either produce useful and readable declaration of generic functions, and when the requirements are not satisfied in the usage of generic function, a readable compiler error on one hand, or disable the generic functions for some types on the other hand. In this lecture, I'll first show how to constrain the generic function add1 with the requirements that we laid out in the last lecture, and how to make them work with both numerical values and repeat the exercise with the function add2container, which is slightly more complex with two template parameters and the unobvious requirements on the value, which should be a copyable type. So let's first start with the function add1. I have written down the add1 function in another file, so let me open that. Since C++ 20, there's a new keyword called requires, which can be used to constrain the template parameters in a generic program. Let's see what the CPP reference page has to say about the requires keyword. If we look through the CPP reference page, we see that the requires keyword has been used to specify requirements on template parameters in the code snippets and examples. However, if we scroll down to the second half of the page, here we go. The reference explains on how to use the requires keyword in different ways. There's the requires clause section, a requires expression section. And under the requires expression section, we have simple requirements on template types, requirements on template type, which can be nested within a given type, compound requirements on template type, and nested requirements on template type. So therefore, there's a lot to cover on the requires keyword in modern C++. We will start with the requires clause and constrain the add1 function. CPP reference page says that the requires clause must be followed by some constant expression that evaluates to a Boolean value true or false. This means that the compiler should be able to evaluate the expression at compile time, which makes sense since the code specific to a type has to be generated by the compiler before it could be used at runtime. Based on the value that the compiler obtains from the evaluation of the expression, if the value is true, it implies that all the requirements on the type T has been satisfied and the compiler can generate the code. If the value is false, then the compiler can look for a different overload that satisfies a different set of requirements, or if a different overload is not found, then the compiler can simply throw an error. which by the way is more readable and consequently more debuggable than the non-constrained generic code. So we want to add these requirements to our add1 function. Let me add the first requirement, namely that the type of the value parameter is either integral type or a floating point type. For this, C++ already provides us with some constant expression in the type trait library that can be evaluated at compile time and whose results are Boolean. So let me try to use them directly here. These type trait constant expressions are std is integral v and std is floating point v. So if I use them, I have to first type out the requires keyword, requires, and then simply the constant expression, which is std is integral v, or, which means a Boolean or, std is floating point v. This requirement reads as follows. The template type t should be either a type integral or it should be a type floating point. And this is required to compile the add1 function. With this much change, if I compile the code, I get some compilation error. And these errors stem from the usage of add1 with a reference and a pointer. Here, if we see, there's no matching function call to add 1 with a parameter which is of pointer to a double. And the error says that there's a requirement on the parameter type that it should be either integral or a floating point. Similarly, we get the same error but with the parameter p2, which is a pointer to an integer. Now I want to add the second requirement that if the template parameter t is a pointer type, then it should dereference the pointer and add 1 to it. In this case, I would still like to check that the dereference type is either an integral type or a floating point type. Therefore, I can create a second overload of add1 function that works only with the raw pointers by using another type trait constant expression called std is pointer v. Let me show you how. Let me simply copy this function and paste it here. And since I'm applying only the second constraint, let me remove the first comment. And here in the requires clause, I'll use the type trait expression std is pointer v. Std is pointer v on template parameter t. In the body of the function, I call the first method add1 by dereferencing the pointer value. Add1 dereferencing value. It is val, right? Yeah, val. And in this case, the second overload will call the first overload with the value which is not of pointer type. And the compiler will check that the type is either an integral or a floating point type. If it is, then the code will be generated successfully and the first overload will return a value parameter to the second overload. And here the add value returns a value rather than a pointer. So here I cannot use t, and to make my life easy, I'll use auto and let the compiler reduce the type. Because t is here a pointer to some type. And now if I compile and run the program, I get the result as expected. And now the function works properly. So I talked a lot about how I've used the requires clause. And in the next lecture, I'll summarize the points that I talked about in this lecture and tell you a bit more about the theory of requires clause. See you in the next lecture. Thank you. Hello there. If you enjoyed watching this video, don't forget to hit the like button and subscribe to my YouTube channel. If you have any questions or if you would like to start a discussion on the topic covered in this lecture, please feel free to leave a comment on this video. And lastly, if you are interested to learn more about my courses, then log on to my course website, mastering-modern-cpp-features.thinkific.com. Thank you.